Hi guys, in this video we'll see how to use this real-time XY stage and OPU controller program, which you'll use to make profiles and scan the concave mirror and the freeform Alvarez mirror. Let's go ahead and open the program and run it. And you'll notice the XY stages are in the idle mode. Let's go ahead and turn on the power supply and activate by flicking the switch on the 16-bit amp box. Right. Once you do that, you can enable your X and Y axes, and let's home them. X axis where the sample is attached, and it will step over in between when a profile is made, right? And Y axis where the OPU is attached, and it will make the profile by moving in Y axis. So before we move on, we should first set up the freeform sample to be at the center of the OPU lens, right? To do that, I'll step over by 1 millimeters until the OPU UV light is focused on the edge of the optic. First, let's do the x-axis. And again, if you're looking at the UV light, make sure to wear the safety glasses. So this edge is somewhere around -5. The other edge is around 5, or I would say 4. So let's go to the median, which would be -1. Let's do the same with the y-axis. Around 4 millimeters, it's hitting the edge on the other side. On this side, it's about -4. So the median is 0. So during our scan, we'll make a 6 millimeter long profile. In y-axis, there will be -3 to +3, which will be the profiling axis, and in x-axis, we'll step over by 1 millimeter per profile. We're going to make only 3 profiles in this video. Let's start at -1 and go to -1, 0, and 1, right? We can go and enter those values in this controllers. So y starts at 0. It starts at -3, and it ends at +3. And x starts at -2, and it ends at 0. And we'll step over by 1 millimeter. And you can choose your scan and step over velocities here, right? So once you do that, we'll make the OPU lens oscillate. I've chosen these default values from the other program we looked at. UV lasers on, the photo detector gains are kept at maximum, and the voice call is enabled. Here you can see as the coil moves up and down, the focus error signal is shown in white. And as you bring the sample surface towards the OPU, you can see the focus error signal approaches the value of the travel, which would correspond to the furthest distance away from the surface. I'm gonna put it back toward originally was. You can see this focuser signal happening somewhere in the vicinity of, let's say, in between -1 to -2.5, right? So this will be the focus point, will control the focus error signal throughout the scanning of the surface. And we would choose the value, let's say -0.5, right? These are the PID gain terms. In this video, I'm only going to use the integral control. One way to come up with this value is, the voltage driven to the trans conductance amplifier of the OPU coil is in negative. So we want to be in the negative focus error set point. So we'll choose a positive value here of 0.001. So Ki multiplied by E will be a negative value, thereby driving the voltage going into the current going into the coil would be a negative value, right? Once you set that up, let's start the focus control. The white curve here shows the focus error signal being slowly approaching -0.5, and the red curve shows the PID error. This plot here shows the voltage driven to the coil in red. And once you are satisfied with the controller, let's go ahead and open up this PC save data file, which will save the data. And the data that will be saved are X and Y axis position, coil voltage, which would be proportional to the travel of the lens, and the PID error. Let's run the program. And let's start scanning. To do that, you go here, choose scan Y forward, and start the operation. You can see here the coil moves up and down to keep the focus error signal at our desired -0.5 value, and the y-axis going from -3 to 3. And once it reaches the 3 millimeters, the x-axis will step over from -2 to -1 with a step over value of 1 millimeters, right? And as this y-axis reaches 3 millimeters, the number of profiles completed will be 1, and this will get updated. The first profile is almost done. Now we are stepping over x-axis. You can go a little faster if it'll make things move quicker. All right, we are scanning in the reverse direction now. So this is the second profile. And you'll see the profiles completed indicator getting updated as it reaches -3. Right, we are stepping over again in X by 1 millimeters. That'll be the last profile. Yeah, what you hear in the background is the air compressor pushing air into the air bearing stages. So we are almost at the end of the third profile. Since all the profiling operations are completed, this meandering um, process is finished. So this will turn from white to green. So let's go ahead and disable the X and Y stages. Disable the amp box and turn off the power supply. And since it's been about 10 seconds after I disable this, I can stop the program. Then you can also stop the data logging program. Right, your data will be saved in the location you want it to be saved. Thank you.